Hello. So here you can see I have cellular automata running where sand is falling. And whenever I click spacebar, more sand falls. This is what we're going to be making in this video. So yeah, I'll see you in there. All right, let's jump right into it. So first thing we're going to do is going to go to the material, and I had it colored red, so I'm just going to go ahead and color it yellow. I already did that, but I'm just showing you guys. And then the next thing we're going to do is open up the Voxel Automata script, and I'm just going to delete everything that I've had in here that I figured out, and we're going to start from scratch. Oh, hold on, not everything. Yeah, you know what, we'll just, all right, so if we remember, we have a reference to our store, so let's just say store.update voxels. We had this before, and I'm going to create this in a separate function, so private byte array automata, and it's going to get a byte array of voxels. All right, and then we're going to pass in automata into this. There you go. And why is this? Yep. Okay, so we have to return voxels at the very end. Okay, there you go. Now we have to apply our automata rules. So first, to do automata rules, the first thing we're going to do is we're going to go over every single voxel and then apply the rules to it. So let's just copy this from generate data, and then also we're not going to generate any more train, so we can just delete that. We don't need the noise either. And we're going to render voxels only when someone calls update voxels. All right, so voxel store, let me just check. Voxel store, this is voxel store, okay, and then voxel render is here. Yeah, that should be all. All right, so in voxel automata, we can paste this loop, get rid of that, and now let's work on applying our rules. So first, before we apply our rules, let's create a simple function called private void set voxel. And we're going to take in an int x, int y, int z, and a reference to our byte array of voxels. If you've never seen reference before, this keyword basically just means that anytime we modify this array, it's also modifying the array in here. So we're going to say, we say set voxel here, right? X, y, z, voxels. And ref. Now, if we say voxels 0 is going to equal 1, that's all we have to do. And it successfully edits this out here because it's a reference. So we're pointing back to the original one. We're updating the original. All right, so inside of sec voxel, we're going to do if not voxel utils dot is within voxel buffer bounds, and we're going to do x, y, z. If it's not within the bounds, then return. We're not going to do anything else. We're just going to exit right here and not continue onwards. Otherwise, we're going to say set voxel is going to be voxels and voxel utils dot index 3d x, y, z is going to equal, and at the very end we're going to add the byte voxel, the voxel that we want to set it to. Boom. Then we're going to copy this, and we're going to do the same thing for get voxel. So get voxel. Same thing with return, and we're no longer setting a voxel, so we can do that, and then we're just going to say return this current voxel. Yeah, and that needs to be a byte. So we're going to give back a byte. And in here, if we fail, then we're just going to return 255, which is the biggest voxel we possibly can. And yeah, so 255, we're never going to have 255 voxels, at least not yet. So 255 is just basically like a magic number that just means it's solid. So we'll just use that for now. All right. Now, for each voxel in Automata, so for each voxel, we're going to say get voxel. So the current voxel is byte. Voxel is going to equal get voxel xyz voxels, and there. And then we're going to say if, and we got to pass that as a reference. Actually, for get voxels, it does not need to be a reference since we're not modifying. We're not trying to modify the original one. We're just getting something from it. So if the voxel is 1, which is going to say if it's sand, right? Because right now, by default, when we create this voxels array, everything's 0. By default, C# sets everything to 0. So 1 means it's going to be sand. And in a second, we'll see how we can actually add sand. But for now, let's work on the rules. So if the voxel is sand, so if sand, then if the voxel below it is air, we're going to move it down. So we're going to say if get voxel x, y, z, and voxels, if the voxel at y minus 1 is equal to air, then move sand down, or move down. Let's just say move down. And we're going to say x, y, z, and voxels. Now we have not created move down yet, so we're going to go ahead and do that. We're going to say private void move down. This is going to take an int x, int y, int z, and a reference to our voxels array. All right, and ref. Okay, so we're going to move the current voxel down. So we're going to say move actually sand down, because we're going to be setting it. So first thing we're going to do is we're going to say if, and actually we already did that, if here, if the one below is sand, we're going to say set voxel x, y, z, ref voxels. We're going to set the one that we currently are to 0. And we're going to set the one below us to sand. It's that simple. And we could even change this to move down and just say the voxel to move down. So byte, make it more generic. Move down. And we're going to move sand down by 1, right? And then we could just say the voxel to move down is sand, right? And we're replacing it with air. All right. Now, let's test this out. And to test it out, we're just going to add a voxel at the corner or in the center of our array. So let's go ahead and do that. Let's say if input.get key keycode.space, then add a voxel here. So let's say set voxel at, and we're going to do voxel constants dot resolution divided by 2, and voxel constants, and we're just going to do voxel constants dot height minus 1, and we're going to say minus 1 divided by 2. There we go. That puts it in the center in the x, at the very top in the y, and again in the very center in the z. And we're going to set that to a sand block. And of course we need a reference to the voxels. So everything should be set up. And if we go into Unity now. Oh, and I forgot one other thing. We can do this. but you're going to see that everything moves extremely fast. So in a second we'll add a simulation scale, but this should work. So if we open up Unity and I click space, boom, we got sand. It immediately filled up. If I click play again and I just click really quickly once, you'll see the sand fell super fast. So to slow it down, we're going to do something. We're going to say serialize field, private float, simulation, I forgot what it was, simulation time, step. I forgot what it was. Just give me 1 second. And I'm looking right now at my friend's code. So let's see, what was it? Simulation interval. That's right. So simulation interval. And we're just going to set that to 0.1, 0.05, which is still pretty fast, but not super fast. Private float, and we're going to say the sim timer, and set that equal to 0. And then in here, what we're going to do is say sim timer plus equals time dot delta time. And then we're going to say if the simulation timer has grown bigger or equal to the interval, then we're going to apply Automata rules. So now if we click play again, oh, and one other thing that we need to do is, after we've applied the simulation interval, we need to reset the timer. Okay, so now, if I wait for Unity to load, and you click play, you should see that sand falls a little more slowly, right? At a visible rate. All right. Now the last step is to get the sand to spread to the sides. So let's work on that. So for that, we're just going to say else if, and I need to reference the code again. Else if the adjacent voxels are empty. So if adjacent, I'm completely spelling that. If is adjacent empty, if adjacent voxels are air, is that how you spell it? Huh. Okay, if the adjacent voxels are empty, so x, y, z voxels, then we'll apply our move outwards rule. But let's create this first. So a private bool is adjacent empty, or is adjacent air, int x, int y, int z, and it's going to be a byte array of voxels. All right. So if get voxel at x minus 1 and y minus 1 and z is equal to air, then we will return true. Yeah, that's right. So if get voxel, and we need to pass in our voxels. All right. If get voxel is 0, if the voxel on our, let me see, on our right and down is air, then we can move to the right and down. And then we're just going to do this for left and down. And then we're also going to do this for forward and down and back and down. Otherwise, we're going to return false. So is adjacent air. All right. Now it's time to move our voxel outwards. So let's go ahead and say private void move outwards, move random, move outwards random direction. And what this is going to do is it's going to look at all the possible moves that we can do, and it's going to pick one at random. So we're going to take in an int x, int y, int z, and a byte array of voxels. And that's also going to be a reference since we're going to be modifying it. And in here, we need to check which possibilities contain a move that we can do. So we're going to store a list of int 3s, I believe. Let me just check what this was. Yeah, so a list of int 3s, and we're just going to add using unity.mathematics. So a list of int 3s, we're going to say available directions. I want to say, or available, yeah, directions. That's going to be a new list of int 3s, and then in here, instead of returning true like we were doing there, I copy pasted this. We're going to add to our list of available directions dot add. And what we can do is we can just copy the position that we did in there. That's going to be a new int 3 and paste that in. Boom. So now we just got to do that for all of them. And that's all 4 possible move directions. All right, so -1 and z +1 and z -1. -1. All right, so then we will do if available directions dot count is greater than 0, meaning there is an available direction, then we will move to one of those. So we're going to say set voxel, and actually, before we do that, let me just double check. Yeah. Okay, so int 3, the direction to move to, so the random direction is going to equal a new int 3 that's going to contain our position. And actually, I already did it here. So I added our position plus an offset. So in here, I can literally just say voxel utils dot index 3d, and we're going to say available directions dot x and available, and actually since available directions is an integer 3 and the index 3d takes in an int 3, we can just do that, and that's going to equal sand. All right, so and in here we're just going to say byte voxel, the voxel to move, right, the type that we're going to move outwards. Let's just paste this in here. Move random direction. Oh. And we're going to pass x, y, z, voxels, and the voxel to move is that we're going to replace it with is sand. And that does not, oh, that does need to be a reference. That's right, because we're modifying the list. All right, now, out of the available directions, right, this is a list. So we're going to pick one. So we're going to say random.range. And because we're using unity.mathematics, it conflicts with random in unity.mathematics. So if I say random, it's not working. So we're going to do unity engine.random.range and range. And we're going to say 0 to available directions.count. Boom. And then we're going to replace the current voxel. So we just created a new voxel to we just created a new voxel. So set new voxel, move voxel clear old voxel. And in here, we're going to replace it with a 0 for air. And instead of the available directions random, we are going to do just our x, y, and z. Yeah. And that should work. And actually, instead of doing the voxels there, what I have to do is set voxel. So set voxel equal to this. That's gonna be too painful. Yeah, there we go. Set voxel there, and I believe there. Now I just need to replace that with voxels and the voxel to replace it with. So we're going to say sand. But actually I'm wrong, because in 3, new voxel, so new index is going to equal available directions. Boom. So new index dot x, new index dot y, and new index dot z, and a reference to our voxels. There we go. And then the final thing is set voxel again, but this time we're just going to replace the old one. So x, y, z with air, and a reference to our voxels array. So move the voxel, or replace place it. Well, yeah, move the voxel, create the new one, and remove the old. And now, if we click play, you should see sand falling. Yep. And the sand falls using our automata rules. And that's it for this video. I'll see you in the next one.